Okay. Now let us summarize the QED Feynman rule. In the previous class we have shown that Lagrangian for electron and photon is photons free field Lagrangian is like that, and electrons, free electrons like Lagrangian is like that. And by replacing covariant derivative, we have obtained this current, right? And the current was Q psi dagger psi bar gamma mu psi, okay? And Feynman rule for current is a minus I something, right? So this vertex was minus I charge gamma mu, and this psi and psi bar contains the wave function of the spin 1/2 particle, and we have shown that the solution to the Dirac equation are composed of positive energy solution and negative energy solution. And if we insert that solution, then there are many possibilities. For example, positive energy solution comes in and goes out. In that case, this kind of case, electron is going forward. So incoming electron is having some interaction with the photon, and then it goes out as a final state with momentum k. That in the psi, if initial state is positive energy solution, the solution is U of P. U is a U spinner, and the space-time oscillating vector is composed of exponential minus I P dot x. And for the final state electron that has a positive energy solution is going out, then the contribution from psi bar for that contribution is this. Space-time oscillating vector is flipped, it's a complex conjugate, but the transformation between the initial and final state is just taking bar. That means U dagger gamma 0, that is U bar. But in the solution for the Dirac equation has negative solution too. But people have found that negative energy solution is exactly the same as the solution for opposite charge with the same mass. The particle with opposite charge with the same mass as the particle is called antiparticle. For example, positron we call is an E plus and electron is E minus. They have the same mass, but only the charge is different. That is just opposite. People have shown that the solution for this positive charge, the charge conjugation state, is exactly the same as the solution of particle with negative energy and momentum. So it is just the same as in real world, the positron is going forward, but positron, we do not have to solve the equation once again, but just copy the result for the negative energy solution, mimic the wave function for this mu plus is the antiparticle of mu1. Mu1 is just like electron, but it has a large mass. It behaves like negative energy mu1, not anti-mu1. Mu minus is coming in from the future to the past. Okay? Negative energy and opposite momentum is coming from the future to the past. That can be exactly the same as the solution for the positive energy. Anti-mu1 is going forward. Okay, so final state, for example, this one, final state anti-mu1 or final state positron, that kind of one, a wave function can be treated as opposite one. Psi is the initial state for a particle, but psi becomes the final state for antiparticle. Yeah? Because it's flowing backward. But we have to think about this exponential factor. If I make use of some momentum of particle or antiparticle, anything what we measure has the positive energy. Okay? So the time oscillating factor for antiparticles momentum must have the same feature as the final one. Final one has this kind of form. Okay? So the sign is flipped here. Okay? You will guess that it looks like if you substitute in this expression, substitute minus p to p, then you will get this. Actually, that is the case. Okay? So here, even though it is a final state anti-mu1, but it looks like mu1, negative energy mu1 is going in this way. So this line is just this one here. This I have put arrows. This arrow means fermion flow. That means in case we put the direction, this arrow should be always parallel to the direction of the motion of a particle, not antiparticle. Our theory, this Lagrangian is for the electrons Lagrangian. This Lagrangian is not for the positrons Lagrangian. So electron, positive energy electron, that is just electron, is going forward, but negative energy electron must go backward. So arrow represents the direction of motion of a particle, whether it is a positive energy, has a positive energy or negative energy. But in fact, the negative energy solution, that part is for the positive energy antiparticle, the opposite two. Okay? So psi contains a positive energy solution, negative energy solution, and for the positive energy solution, it is a U spinor e to the minus ipx. For negative energy, just to put minus p then this is a final state of antiparticle. Final state of antiparticle. Okay? Psi bar, just to flip everything. Okay, U becomes U bar, V becomes V bar, and the final state electron particle, final state particle has exponential plus IPX, and this initial state antiparticle, initial, so e to the minus I, p dot x. In Feynman rule, we use only this kind of momentum space wave function. This part, this oscillating part, has been already contained in the phase space. Remember? All those kind of things are combined, and when we integrate over the interaction point, then it generates the energy momentum conservation delta function, right? And there are two delta functions, and one delta function has been removed by taking the ratio. We have divided the space and time because the interaction rate was proportional to the space and time because of delta zero, right? Four-dimensional delta function, delta zero. So we have divided that one, and remaining one energy momentum conservation delta function was contained in the phase space, right? So when we write down the invariant amplitude, what we do is just collect those wave functions and collect the vertex. In the vertex, if I have the J mu, then I put minus I J mu and remove the wave function part. Then vertex is minus I Q gamma mu. That's it. So I copy that vertex here and that vertex here and attach wave functions for the correct state. Suppose we consider E minus mu plus to E minus mu plus. Then they are moving like that. Mu plus is the same as negative energy. Mu minus is coming from the future to the past. So invariant amplitude is vertex. If I write it, this is the vertex. This is the vertex, and attach wave functions. Initial state wave function here is attached here. Final state electron, U bar K1. So final state anti-mu1. Final state anti-mu1 is here, upside down. And initial state anti-mu1 is here. Remember, this momentum, everything appearing in this expression, they have all positive energy, right? And we have propagator, photon propagator. So this is the invariant amplitude. So what you do is just make use of Feynman rule to construct the invariant amplitude and square the invariant amplitude here. What about the case for E minus, mu minus, going to E minus, mu minus? Okay. then everything is a positive energy solution. Okay? We have same thing. This is the same. I don't have to explain one more time. But in case of this mu1, this is mu1, positive energy solution can be used, then initial state is UP2 and final state is U bar K2. Okay? UP2, U bar K2. Correct direction. But still, I don't have any e to the ikx style. These factors are already factored out, and they are contained in here. So I don't calculate it again. Everything is there. So everything is just a momentum space expression. Okay? I comes from this propagator plus IE. Each plus I comes from these vertex. So when you square this, you divide this state by the flux and multiply it by phase space. In this kind of case, we have head-on collision of two particles, and in the center of mass frame, center of momentum frame, the two particles will be back to back because the three momentum of the initial state is 0 and three momentum of the final state is also 0. So we can define some scattering angle theta, and there's distribution over angle theta. So this angle theta dependence can be integrated all out to get the sigma total. Total cross section is just integration of that over the whole phase space. Then you will get the total cross section. Okay, that's it.